This is the brief on vanishing surface integrals, where we're looking at how a really nasty calculus problem actually simplifies down to zero. Okay, so the source material we're looking at tackles a complex vector calculus problem. It shows how a specific surface integral, that's kind of like summing up values all over a curved shape, just completely cancels itself out. And it does this with great 3D visuals, so you can actually see why it happens. All right, so let's get into the takeaways. First, the whole thing absolutely hinges on one condition. You have this scalar field, let's just call it a temperature map on the surface. Well, for the integral to vanish, that temperature has to be the exact same all along the outer rim. If that boundary value isn't constant, the whole thing falls apart. Second, the proof uses a really powerful shortcut, Stokes Theorem. This amazing tool lets you just ignore everything in the middle of the surface and focus only on its edge. And because we know that temperature is constant along that edge, the theorem just forces the whole calculation to collapse to zero. Simple as that. And finally, this has a great real-world parallel with physics, specifically with conservative fields like gravity. You know, if you walk in a loop, you might go up and down, but you end up right back where you started. Your net change in height is zero. That's what's happening here. The positive and negative parts just perfectly cancel out. So it all comes down to this. A constant value on the boundary means the laws of math guarantee a perfect balance to zero.